Welcome back. Right now we're going to be looking at a process of inputting functions into functions. In a function, the g of x, the x-x is a placeholder for our input. So anytime we see x for a function means whatever's inside of parentheses, that's what gets put in for the place of x. You kind of think of functions as a giant machine. For a giant machine of g of x equals x squared plus 3, our input, whatever we're going to do, we're going to square our input, and then 3 subtract, this should be minus x squared of x squared minus 3. We're going to subtract 3 from it. So whatever we input, we're going to square it, subtract 3. When we see g of negative 5, well, that's inputting negative 5, square it, subtract 3. 25 minus 3, which equals 22. When we see something with a variable, still, square it, subtract 3. 25t squared minus 3. In this case, we're left with an expression, but that's okay. And finally, even when we see an expression with two terms, t minus 4, we still subtract it, or square it, and then subtract. That becomes t squared minus 8t plus 16 minus 3, which equals t squared minus 8t plus 13. This last example of g of t minus 4 is something really special. The reason why is t minus 4 is a function itself. When the input value is a function, the process of input and output is called the composition of functions. The composition of functions with f with g is defined by saying f of g of x, which is another way of saying f of g of x. The diagram is kind of a visual way of representing this. What it's saying is it's going to start with x. We're going to put it into our g of x and we're going to kick out some number. When we kick out that number or that expression, that is what now gets put into our f to get f of g of x. So let's take a look at a couple examples, and let's take a couple examples with expressions, and then we can go with specific values. When we look at f of g of x, another way of saying it is, again, f of g of x. That is f of, well, our g of x is the square root of x plus 3, which equals f, so anywhere, what's inside our parentheses now is the square root of x plus 3. So that is going to go in place. Okay, someone just walked in and I had to talk to them, so I don't know where I left off. I paused the recording, but I'll pick up at this. We know that our input is the square root of x plus 3. Just like we've seen x here, that means anywhere we see an x, we're going to write the square root of x plus 3. So f of the square root of x plus 3 will equal negative 5 times the square root of x plus 3 plus 3. We can distribute to get negative 5 square roots of x plus 3 plus 3. That's it. That's our new function rule. We can't really do anything from there. We can't simplify. So that's it. Looking at g of f of x, g of f of x, we can take a look to say that g of negative 5x plus 3 equals, again, now our input in this case is 5x, negative 5x plus 3. So in goes negative, the square root of negative 5x plus 3 in for that x. In this case, we can simplify a little bit to get the square root of negative 5x plus 6. When we try to find the domain of these compositions, we have to start with the domain of whatever our input is. So for the domain of f of g of x, we can say the domain of f or g of x is all real numbers. But when we take a look at f of g of x itself, when we get that negative 5 times the square root of x plus 3, we can notice that once again we have a square root, so x plus 3 has to be greater than or equal to 0, which means x has to be greater than or equal to negative 3. Again, that's for f of g of x. Looking at g of f of x, when we start, we have to realize what is our possible input for f of x. If f of x, again, the domain for f of x is all real numbers. That's coming from the negative 5x plus 3, which means we can input anything into our g of x. When we input our f of x, what we're left with is the square root of negative 5x plus 6. Because of this, all we have to say is when is that square root going to be greater than or equal to 0? The square root of 5x plus 6 has to be greater than or equal to 0, which means that negative 5x has to be greater than or equal to negative 6, which means that x has to be greater than or equal to 6/5. Moving on, we're given a function f of x equals 2x over x minus 5, g of x equals 3 over x. So when we're looking for f of g of x, that's going to be f of 3 over x, which equals 2 times 3 over x. Again, remember, 3 over x is what we're inputting into our function. So anytime we see that x, we'll write 3 over x over 3 over x minus 5. This is a complex fraction. When we start to simplify, we'll see it's 6 over x over 3x minus 5. In order to simplify our whole denominator, we're going to realize that the common denominator between 3 over x and 5 over 1 is x. So when we multiply this by x over x, we're left with 6 over x all over 3 minus 5x all over our common denominator of x. We can multiply this by reciprocals to say 6 over x times x over 3 minus 5x equals, well, all those x's cancel. We're left with 6 over 3 minus 5x. The question remaining in this problem is a little bit more tricky. We have to take a look at f of g of x. What is the domain of g of x? Because that's what we're inputting right here. Excluded from our domain is going to be that x equals 0. In this case, for our domain, x cannot equal 0 because we'd be dividing by 0 within the function g of x, which is our input. When we go to our final solution of 6 over 3 minus 5x, once again, 3 minus 5x cannot equal 0 because we'd be dividing by 0, which means 3 cannot equal 5x, which means that x cannot equal 3/5, which means we have all real numbers, except for x cannot equal 0 or 3/5.